Good day, grade 11. This is teacher Riza. Today we're going to discuss our lesson 3 for week 2 of second quarter in general mathematics. With our learning competency, the learner computes interest, maturity value, future value, and present value in simple interest and compound interest environment. From this lesson, you will learn how simple and compound interest works, how they are used in daily life, and how simple interest and compound interest are calculated. Let us review our previous lesson, how to find for the simple interest, that is by multiplying the principal, rate, and time. And to find for the maturity value of simple interest, we're going to add the principal and simple interest. For example, find the maturity value if Sarah deposits 20,000 pesos at a bank for 3 years at an interest rate of 4% per year. Using simple interest, which is multiplying the principal rate times time, wherein principal is 20,000 pesos, and rate is 4% or 0.04 and time is 3. Multiplying 20,000 times 0.04 times 3 is equal to 2,400. So after 3 years, the 20,000 deposited in the bank will earn an interest of 2,400 pesos. And to find for the future value, we're going to add the principal and the computed simple interest, wherein the principal is 20,000 pesos and the computed interest while ago is 2,400. So we have the future value is 22,400. So therefore, the money will grow to 22,400 pesos. And to find for the compound interest, we're going to subtract principal from the future value. And for the maturity value of compound interest, that is F is equal to principal times quantity 1 plus rate raised to T, which is term or time in years. For example, find the maturity value and compound interest if 30,000 is invested at 3% compounded annually for 6 years. So using F is equal to P times quantity 1 plus R raised to T, wherein the principal is 30,000 and the rate is 0.03 and time is 6. And 1.03 raised to 6th power is equal to 1.1941. Multiply to 30,000, so we have 35,821.57. And to find for the compound interest, subtract future value less principal, wherein the future value computed is 35,821.57 and the principal is 30,000. Subtracting these two, so we have now 5,821 pesos and 57 centavos. Thus, 30,000 invested at 3% compounded annually for 6 years will earn an interest of 5,821 pesos and 57 centavos. Therefore, the money will grow to 35,821 pesos and 57 centavos. Now, how to find for the present value of compound interest? From the future value, we're going to subtract by 1 plus R raised to T. So we have now the present value is equal to future value divided by 1 plus R raised to T, or that is F times quantity 1 plus R raised to negative T, wherein P is the principal or present value, F is the maturity or future value at the end of the term, and R is the interest rate, and T is the term or time in years. For example, find the present value of 70,000 due in 5 years at 6% compounded annually. So what are given the problem? We have future value is 70,000, rate is 6% or 0.06, time is 5 years. So what we're going to find is the present value. Using the formula P is equal to F over 1 plus R raised to T, where in future is 70,000 and R is 0.06 and T is 5. So we have 1.06 raised to 5 is equal to 1.338226. Dividing 70,000 by 1.83338226 is equal now to 52,308 pesos and 6 centavos. So therefore, the present value is 52,308 pesos and 6 centavos. What is the present value of 50,000 due in 7 years if money is worth 10,000 compounded annually? So we have given future value is 50,000, rate is 10,000, 10% or 0.1, then T is 7 years. So what we're going to find is P. So the future value now is 50,000 over 1 plus 0.1, which is rate, and T is 7. And 50,000 divided by 1.948771, which is the value of 1.01 raised to 7, is equal to 25,657 pesos and 91 centavos. So the present value is 25,657 pesos and 91 centavos. Interest is often compounded more than once a year. For example, semi-annually means twice a year, or the interest is every 6 months. Another is quarterly, means 4 times a year, or the interest is compounded every 3 months. We have also monthly, means 12 times a year, or the interest is compounded every month. And we have also daily, and that is 365 times a year. That means the interest is compounded every day. And that's we call frequency of conversion period. So we define conversion or interest period as the time between successive conversion of interest. And frequency of conversion, or M, is the number of conversion periods in 1 year. And the nominal rate, which is I raised to M, is the annual rate of interest. To find for the rate, or J, of interest for each conversion period, we have now the conversion period, or the interest per conversion period J, is equal to I raised to M, which is the annual rate of interest, over M, which is the frequency of conversion. And the total number of conversion period, which is N, is equal to M times T, wherein M is the frequency of conversion, times T is the time in years. For example, we have 2% compounded annually. Annually means once a year, so the value of M here is 1. To find for J, or interest rate per conversion period, we're going to divide the 2%, which is 0.02 by 1, so that's still 0.02 or 2%. And the conversion per period is once a year or every 1 year. Next, we have 2% compounded semi-annually. So we use I squared because this is semi-annually, wherein the value of M is 2, means twice a year. And to find for the interest rate per conversion period, we're going to divide the rate 0.02 by 2 because that is semi-annually or twice a year. So we have 0.01, or that is equal to 1%. Means the interest is every 6 months, and that is the conversion period. Next, we have 2% compounded quarterly. Quarterly means 4 times a year, so that's the value of M. So we have I raised to 4 is equal to 0.02. And to find for the interest rate, we're going to divide 0.02 by 4 because it is quarterly, which is equal to 0.005 or 0.5%. And the conversion period is every 3 months. Next, we have 2% compounded monthly. So that is I raised to 12 because that is 12 times a year. So we're going to divide 0.02 by 12. That is equal to 0.0016 or that is equal to 0.16%. And the interest is every month or 1 month. And 2% compounded daily, that is I raised to 365, which is 0.02. So dividing 0.02 by 365, so we have 0.0005479, or that is 0.005%, wherein the conversion period is 1 day. To find for the maturity value or compounding m times a year, so we have now f is equal to p times quantity 1 plus I raised to m over m raised to mt, where f is the maturity or future value, p is the principal, I raised to m is the nominal rate of interest per annual rate, and m is the frequency conversion, and t is term or time in years. Or we can use this formula, f is equal to p times 1 plus j raised to n, but we're going to solve for the value of j, that is j is equal to I raised to m over m, and the value of n, which is m times t. For example, find the maturity value and interest if 15,000 is deposited in the bank at 3% compounded quarterly for 5 years. So given in the problem, we have principal is 15,000, I raised to m is 3% or 0.03, and t is equal to 5, and m is equal to 4, and future value is unknown. Using f is equal to p times quantity 1 plus I raised to m over m plus I raised to m over m raised to mt, wherein the principal is 15,000 and I raised to m is 0.03 and m is 4. Then raised to 4 times 5. And 4 times 5 is equal to 20. And 1 plus 0.03 divided by 4 is equal to 0.0075. Adding 1 plus 0.0075 is 1.0075 raised to 20 is equal to 1.161184 multiplied to 15,000. So we have now 17,417 pesos and 76 centavos. So this is the maturity value after 5 years. And we can also use this f is equal to p times 1 plus j raised to n. But we're going to solve for j, that is the value of I raised to m is 0.03, that is the rate. Then m is 4 divided by 0.03 divided by 4 is equal to 0.0075. And multiplying m times t, that's 4 times 5 is equal to 20. So we have now 15,001 plus j, which is 0.0075 raised to 20, and 1.0075 raised to 20 is equal to 1.161184 multiplied to 15,000, still the answer is 17,417 pesos and 76 centavos. That means you can use any of the two given formula. And to find for the present value of compound interest, so we have now P is equal to F over 1 plus I raised to M over M raised to MT, wherein F is still the maturity or future value, P is the principal, I raised to M is the nominal rate of interest, and M is the frequency of conversion, and T is term or time in years. Or we can use also P is equal to F over 1 plus J raised to N, but we're going to find first the value of J, that is I raised to M over M, and the value of N, which is M times T. For example, find the present value if 50,000 due in 5 years if money is invested at 9% compounded semi-annually. So given in the problem, we have future value is 50,000 and I raised to M is 9% or 0.09, and M is equal to 2 because that is semi-annually, and T is 5. So what we're going to find is the value of P. So we're going to use the formula P is equal to F over 1 plus J raised to N. And solving for J, we have I raised to M over M, wherein the value of I raised to M is 0.09 and M is 2, which is equal to 0.045. And to find the value of N, multiply 2 times 5, so we have 10. Substituting now the value of the future value, we have 50,000 over 1 plus the value of J, which is 0.045, raised to the value of N, which is 10. And 1.045 raised to 10 is equal to 1.5529694. Dividing 50,000 by 1.5529694, so we have now 32,196 pesos and 38 centavos. So this is now the present value of 50,000. So the present value is 32,196 pesos and 38 centavos, which is due in 5 years. For your exercises, for exercise 1, we have simple interest. That is, complete the table by finding the unknown. So we have the first column is the principal, second column is rate, third column is time, then fourth column is interest, and the last column is the maturity or future value. So for number 1, unknown is rate. Since this is simple interest, so we're going to use I sub S is equal to PRT, wherein the principal given in the problem is 25,000, but first we're going to find for the simple interest, which is 10,000, is equal to the principal 25,000, and rate is unknown, and time is 5. So multiply 25,000 times 5, so we have 125,000 times R. And dividing both sides by 125,000 to get the value of R, so we have now R is equal to 10,000 over 125 pesos, 125, which is equal to 0.08 or 8%. So therefore, the rate is 8%. And for number 2, we're going to find for the principal, and number 3, we're going to find for the maturity value. So using simple interest equal to PRT, wherein simple interest given is 9,000 and principal is unknown, and rate is 5% or the 0.05, and time is 2. Multiplying 0.05 times 2, that is 0.1. Dividing both sides by 0.1 to get the value of P, so we have 9,000 divided by 0.1 is equal to 90,000 pesos. And to find for the maturity value, we're going to add the computed principal plus simple interest. So wherein the principal is 90,000 plus simple interest given is 9,000. So we have now the future value is 99,000 pesos. So number 1 and 2 is already solved, wherein the answer for number 1 is 8%, for number 2 is 90,000 pesos, and for number 3 is 99,000 pesos. So what you're going to do now is continue solving for number 4 and 10 to complete the table, but you're going to show your solution. And for exercise 2.1, which is compound interest, so the same, you're going to complete the table So for number 1, so we're going to solve for number 7 and 8. Wherein for number 7, unknown is principal and number 8 is the interest. Since this is compound interest, so we're going to use f is equal to p times 1 plus r raised to t. Then substitute the value of the future value, which is given in the table, which is 200,000 pesos, is equal to rate is 5% or 0.5 and time is 10. And 1.05 raised to 10 is equal to 1.6288946. Dividing both sides by 1.6288946. So we have now P is equal to 200 divided by 1.6288946, which is equal to 122,782 pesos and 65 centavos. And to find for the compound interest, subtract future and principal. Wherein the future value is 200,000 and the principal computed is 122,782.65. So we have now 77,217 pesos and 35 centavos. So the answer for the principal is 122,782.65 and interest is 77,217.35. So number 7 and 8 is already solved for you. So what you're going to do now is solve for number 1 to 6 and 9 to 10. And for exercise 2.2, you're going to complete the table by finding the unknown, wherein we have the column of principal, nominal rate, frequency of conversion, interest rate, time, total number of conversion, which is N, compounded interest, which is I, and compound amount, which is F. For number 1, 2, 3, and 4, unknown is interest rate for number 1. Number 2 is the number of conversion, which is N. For number 3 is compound interest. And number 4 is the compound amount or future value. And to solve for this one, we're going to use P is equal to F over 1 plus J raised to N. Wherein the present value or the principal is 5,000. Future or compound amount is unknown, and rate is, we have 0.01 raised to 60. How do we get that 0.01? By dividing 12% or 0.12 by 12, because the frequency conversion is 12, that is equal to 0.01 or 1%. Then how do we get that 60? That is, N is equal to M, that is 12 times 5 is equal to 60. So we have now 1.01 raised to 60 is equal to 1.8166967. Then by cross multiplying to get the value of the future value, that's 5,000 times 1.8166967. So therefore the future value is 9,083 pesos and 48 centavos. And to find for the compound interest, that is future less principal. So that is 9,083 pesos and 48 centavos less 5,000 is equal to 4,083 pesos and 48 centavos. So therefore, we have already answered for number 1, which is 1%. For number 2 is 60. For number 3 is 4,083 pesos and 48 centavos. And number 4 is 9,083 pesos and 48 centavos. So you're going to continue solving for number 5 to 15 to complete the table. And for your reflection, what meaningful lesson have you learned from this topic? You're going to write your answer in a clean sheet of paper. And think of this. So before we end this lesson, let me share this. It's good to have a special price to pay for the future, and it will pay you in return in the exact way you would wish to be paid. Again, this is Teacher Riza saying thank you for listening till our next lesson again. Have a nice day.